My name is Joey Rodriguez. I'm an assistant professor in the Department of Physics and Astronomy here at Michigan State. Over the last 30 years, the field of exoplanets has gone from its infancy to one of the largest growing subfields of astronomy. During that time, we've gone from having a few planets to now having thousands of planets all across our galaxy, but many questions still remain. And in particular, questions that started from the first discoveries in the early 1990s, where we were finding gas giant planets similar to Jupiter, but orbiting their stars on only a few days. This sort of threw a wrench in our understanding of how planets form and evolve, and while we commonly believe that planets must form farther out from their star, where Jupiter is today in our solar system, and through different processes must migrate to these close origins, it's not very clear how that migration is done and what mechanisms dominate that. One piece of evidence that can really tell the story is the eccentricity of the orbit. If the planet is actually interacting with other bodies in the system, it'll get shot into a very close-in orbit very quickly and will reside in a very eccentric or elliptical orbit. That is sort of the evidence that we are looking for. So in this study, we present the discovery of 6 new giant planets orbiting their stars within periods less than about 15 days. These discoveries come from NASA's Transiting Exoplanets Survey Satellite, or TESS mission. And what TESS does is it scours the night sky trying to look for transits, or these rare instances when the planet's orbit perfectly lines up with our line of sight and passes in front of the star, blocking out a small amount of that light. We can use that information combined with other techniques to determine all the properties about the planet, including its eccentricity or its orbital eccentricity, and then look at the resulting population of eccentricity distributions for these planets that we now have hundreds of, and see does it match the theories for the different types of migration methods that could put these planets into these very, very close-in orbits. In this study, we showed that the current population of giant planets' orbital eccentricities are consistent with them migrating through interactions with other planets or other bodies within the system. And the hope is that as we discover more and more systems with TESS, we'll be able to sort of disentangle that true dominant mechanism that puts these planets into these very close-in configurations.